Hello and welcome. My name is Shreya Verma. I'm a program manager with the SQL Server and Azure SQL Database team. And today we are going to be talking about the graph extensions that we have introduced in SQL Server 2017 and Azure SQL Database. So let's get started. But before I go ahead and talk about the details, let's first try to understand what is a graph database. So a graph database is nothing but a collection of nodes and edges. Nodes represent your entities and edges represent your relationship. So what is different from a relational database really? Because tables represent my entities and foreign keys represent the relationships. But so the difference is that the edges in a graph database can have attributes or properties associated to them, right? They are first-class citizens in the database, and that's why they can have their own attributes. And they can heterogeneously connect different kind of nodes with each other. For example, here on the screen, you can see that Bob is connected to city and an industry using the from edge, the same edge, right? So you can use the same type of edge to connect different type of nodes in your database. Both graph database and relational databases can do OLTP and OLAP type of queries. And in a graph database, you can express your pattern matching or graph traversal queries a bit easily using an easier syntax. So they make it easier for you, right? Now let's look at what is new in SQL Server 2017 or Azure SQL Database. So now you can create a graph in your database. There can be only one graph per database. You can create multiple logical graphs, but they eventually belong to same physical graph. There are some language extensions, DDL extensions, which will allow you to create nodes and edges, node or edge tables, and query language extensions, which will allow you to write pattern matching or graph traversal queries. The tooling and ecosystem that you have been using with SQL Server and with other features till now, you can continue to use the same tools and ecosystem with graph features. That means you don't have to learn a new language because we have introduced T-SQL extensions for graph pattern matching. And that means you don't have to learn new tools to be used with this database, right? Let's discuss some of the DDL extensions that we have introduced. So now you can create a table as a node. Creating a table as a node is very simple. You just create a table and then add as node in the end to create a node table. All type of data types are supported. So you can create all type of, use any type of data type. And you can create constraints. You can create any type of indexes on these tables, including the clustered column store and non-clustered column store index. But what happens when you create a node table? And why are we creating this special type of table if it is just a table, right? So when you create a node table, we create one implicit column inside that table for you, which is called $node_ID. This column is a unique identifier for every node in the database. It is, when you select from this table, it will appear as a JSON string. However, it is stored as an integer internally. Let's look at the syntax for create edge. So it is again straightforward, just like creating a regular table. You just add as edge keyword in the end to create an edge table. And edges may or may not have any user-defined attributes associated to them. For example, here you can see that the from edge does not have any user-defined attribute associated to it, right? So it has no columns basically. And what happens when you create an edge table? And why are we creating this special type of table, right? So when you create an edge table, we create three implicit columns for you. First is $edge_ID, which is the unique identifier for that edge in the database. And then $from_ID and $to_ID, which actually specify the nodes, which are the node IDs for the nodes that this edge is going to connect, right? So if you notice when you created the edge table, in the create edge table syntax, we never specified the type of nodes that this edge is going to connect. So it's only when you insert the data into the edge table, you can provide values for $from_ID and $to_ID, and that's when the engine knows which nodes this edge is going to connect. And this will allow you to heterogeneously connect any nodes with using the same edge, right? For example, here, the attendee node is connected to location using the from edge, and attendee node is also connected to industry using the same from edge. So you are connecting different type of entities to each other using the same edge. Now let's look at how you will insert data into these tables. Inserting into a node table is straightforward. You just provide the attribute names or the column names for which you want to insert the data. And then you either select from a table, existing table, or you insert the values directly into these attributes. Inserting it into an edge, while doing that, you have to provide the $from ID and $to ID values, which are nothing but the node IDs from the nodes that you are connecting to each other using this edge, right? So for example, here on screen, you can see that we are connecting attendee to session node using the attends edge. And we are picking attendee ID and a session ID, and then we retrieve the node IDs for these attendees and sessions, and then we insert those in the attends edge. Let's talk about the query language extensions. So we have introduced a new match predicate or built-in with SQL Server 2017, and this will allow you to write your graph traversals or pattern matching queries. This supports ASCII art style syntax for graph traversals. And if you look at the example here, and if you look at the match predicate there, we can see that we are trying to find all the attendees who have attended this particular session that we are filtering later on in the query. And we go from attendee node to the session node via the attends edge. So anything that appears inside parentheses in that pattern is an edge, and anything that appears at the two ends of the arrow in that pattern is a node table, right? So we go from a node to another node via an edge. So let's look at the session recommendation query using the relational approach. So you start with the current user. You take the sessions that this current user has attended, and then you go ahead and find out the other users who have attended this session, right? From there, you find the other sessions that these users have attended. And then finally, you make recommendation to your current user about the other sessions that other people have attended. Now imagine extending this query with the speaker information of the other sessions. It will not be very straightforward, right? It will not be very easy to extend and even to maintain this query. So now let's look at if the graph approach is going to make it any easier, right? So this is how the query, session recommendation query looks like using the graph approach or the graph implementation. If you look at the match predicate here, we start at the attendee node and we are filtering on the session that we are looking for. So we get all the attendees that have attended this session. The session ID happens to be 101. So we find all the attendees who have attended this session. And from there, we find the other sessions that these attendees have attended, right? And then we finally make those, our current user, the recommendations based on the sessions that we find here. Now, if you want to extend this query to find the speakers, you can easily extend from the recommended sessions to get all the speakers that have presented in these sessions, and you find the speaker names also. So it's very easy to extend this query, maintain this query, and comprehend this query using this graph approach. Now let's look at this query in action in this demo. All right, so now you can see that we are using SSMS and we are connecting to Connect demo, which is a session application demo that we have created for this demo. And I'm just going to run a simple match query first that demonstrates how match predicate works. And we are basically just trying to find all the attendees who have attended a session. So let's run this query and we get a list of all the attendees who have attended a session in the conference, right? So like I said before, we are going from the attendee node to the session node via the attends edge. So anything that you see inside parentheses here is edge, and anything that is on the ends of the arrow is a node, right? Or a node table or a node type. Now let's look at the session recommendation query that we saw there on the screen. And here I am trying to find I'm trying to make recommendations to my user, Robert Kosick. And the session that he attended was building a graph database application. And I'm trying to make him set recommendations based on the other sessions that the users have attended. And when I run this query, it came back pretty fast, and it shows you the other sessions that these users have attended after attending the graph session or before attending the graph session, right? Now, Robert, after he finds all the, based on these recommendations here, he goes ahead and attends all these sessions. And after attending these sessions, now he wants to socialize with some of the people who have attended in these sessions because he wants to grow his network, right? And so what he does is he writes a quick query to find out the people who have attended the same sessions as he has attended, right? And he gets a list of all the people. So if you look at the match query here, what we are trying to do is our attendee, Robert, has attended a session, and we are trying to find all the other attendees who have attended these sessions that Robert has attended, right? So we go ahead and run this query and find out all the attendees that Robert can connect to. Now, after finding all these attendee lists, maybe Robert wants to connect to some person that he recognizes from that list, or maybe he wants to work with them, right? So we see that Robert wants to connect with Camille from the list. And so now he doesn't know what's the best way to connect to Camille. So what he does is he writes a shortest path query to find the shortest path or the people who can connect him to Camille. And today you cannot write a shortest path query using the graph extensions, or rather natively, we do not have a built-in function that will allow you to write a shortest path query. So what you can do is you can use a workaround using T-SQL loops or stored procedures. And this workaround basically just implements a breadth first search algorithm to get you the shortest path between two users. And the two users here happen to be Robert and Camille. And let's run this query here. And after running this query, Robert finds out that Camille is 6 hops away from him in the social graph. And these are all the people who appear between him and Camille who can connect him to Camille, right? So there are workarounds today that you can use while using the graph feature that will allow you to achieve what you are trying to achieve in your application. And we have documented these workarounds on GitHub, and soon I'll be sharing with you the links that you can refer to for examples. All right, so now that we have seen the demo, let's talk about when should you use graph approach over relational approach, or vice versa. There's nothing that a graph database can help you solve which a relational database cannot, and we have shown you. We have shown you that you can write the recommendation system query using relational approach as well as the graph approach. But if relationships define the primary application requirement, then graph approach can help you solve your problems more intuitively and with less code. Now let's look at some of the graph database scenarios that we have seen so far in SQL Server 2017. So graph has been out in private preview since January of 2017. And we have seen our customers using this feature for recommendation systems, fraud detection, in content management, a bill of materials where there is a product hierarchy, even in content management where there is a content hierarchy. And then you have to traverse multiple steps to get to the content, or you want to find what all parts make a particular product. Or CRM where you have salespeople working on opportunities or accounts, and they are connected to each other through these relationships, and you traverse these relationships to either find a shortest path between two salespeople or for some analysis. Now let's discuss some of the future improvements that we are working on. We are investing into this feature, and we are interested in looking into shortest path and arbitrary length traverses. We want to make it easier. Today, the match pattern does not allow you to provide an arbitrary length pattern for searching or traversing. For example, if you want to find people who I follow 1 to 5 hops away, there's no easy way to do that using regular expressions. We are looking into how we can make that easier for you. We are looking into heterogeneous associations. For example, if you want to find sessions or speakers that I like, Now, session and speaker, both of them are different kind of entities. And if I want to find what all sessions or speakers are like, today I'll have to write a union query or 2 different queries and then aggregate the results. So we are trying to make this easier using a single query. There will be some language enhancements like in merged DML, where we will support match inside merged DML. And then we will be introducing edge constraints. For example, today an edge can connect any type of node to any other type of node. And using these edge constraints, you will be able to specify the type of nodes that only restrict the type of nodes that these edges can connect. Now, call to action. Please try the graph feature on SQL Server 2017 and Azure SQL Database today. You can read the documentation here. There's graph overview or graph architecture documentation and getting started blog. And then there are some bulk insert practices that you can follow. And we have documented some examples like recommendation system and some advanced graph algorithms like shortest path and others that you can look here into these resources. Thank you very much for joining us today, and we look forward to working with you.